All right, part two. So we just talked about the built-in functions and the operators for a very, very long time. Sorry. And then, so I was looking at this part, and I mean, we kind of already talked about the assignment stuff. Like, if you just remember that it's like x equals 3, not to say like 3 equals x. It's like an easy way to mix it up, because that would be trying to assign x to the number 3, which is like an abstract concept, so it doesn't work, right? And then, so in order to talk about global and local scope, I'm going to talk about functions first, actually. And then this line of variables of value type pair, I guess that's like if you say like x equals 4, then you can just get the value of x and the type of x. But it's probably something special you learned in lectures, so I would just stick with whatever your notes say for that. So let's delve into functions, because functions are very fun, and then we'll talk about global and local stuff. Okay. So, why are functions amazing? So, as I said at the very beginning of the first one, we print 4. This is amazing, right? Like, if I just came into Python and I was like, okay, so my job is I'm going to put a 4, I'm going to put a 4 out here. Like, how do I get it from this window to this window? Okay, I guess I'll import, like, the operating system and, like all through the back. Like, I don't even know how you do that, right? So it's just great that they wrote all that code for us, and we can just use it. Or to put it another way, let's say that we want to take, let's say, x equals 4 and y equals 6. And then we'll say z equals, let's say this is like the Pythagorean theorem or something. So it would be like x squared plus y squared. And then you gotta take the square root of that, right? And then to the 0.5, the square root, right? So let's say we did that, and then we said, okay, print the hypoth whatever is comma z, right? I don't know if it's cast it to a string, right? We already talked about the first video, but yeah. There we go. The whatever is this. Cool. All right, that's great. I did my one WebAssign homework. Okay. Now let's do it again. I have another problem. That's a lot of typing. Okay, here we go. X equals 9. Okay, that takes forever, right? So what we can do, wouldn't it be great if we could just call something like hypot of 4 and 6, and they would just do all this for us, like assign it to x and assign it to y, and then take the hypotenuse and print out this message. So yeah, we can actually do that. So that's the magic of functions. I don't have to rewrite this code every single time. So I can, as you say, abstract it out. But let's do it. Let's do it for just to get an introduction. So you've probably seen this. I do f. I'm going to call it hypot. And it's going to take in x and y. So I don't have to assign x and y here, because those are be coming from whatever they passed in, right? So I'm basically calling the first thing they pass in x and the second thing they pass in y. And then it goes into this formula here and then prints out there. So if I say hypot of 5 and 6, then, oh wow, there it is. There's an answer. And I can also just do this again a bunch of times, like 16 or something. And then that's great. And like when you learn loops, like it would be great. Like you can say like, for I in range, and you'll see this very soon. But hypot of, let's say 2 and that. Then look, I just made all those square roots, and it was so easy. I didn't have to type all that code every single time. So that's great. That's why functions are great, and you've probably seen the magic of them as well. So let's delve into the particulars of them. So the definition, I would just practice writing these a lot, because especially on paper, because it's sometimes hard to remember all the pieces, especially the colon and the parentheses and the comma, right, and the def and the function name. Yeah, I think that's all. Yeah. So let's make another one. Let's say def sum. Sum is already a function in Python. If we type it down here, I think actually it will turn a different color because it's built in. Let's make our own sum, I guess, of x comma y colon. So I have the def. I'm saying, hey Python, I'm making a function. This is what it's called. And this, when I call it, it's going to look like this. Like when they call sum, it's going to be, oh, I want the sum of like 5 and 6, right? So it's kind of cool because it looks like the way that you're going to call it usually, right? So then So it's like, okay, they're gonna call it like this, and the first thing they pass in is me. I'm gonna refer to that as x, and then the second one I'm gonna refer to as y. And now Python, I'm gonna tell you what I want you to do with this, and I want you to return x plus y. So then when I call sum of 5 and 6, then nothing happens, right? Because we just print it because it got returned. We'll talk about that in a second. But there we go. We got the sum of 5 and 6. Yeah. I don't know what else to say. Just practice it. And then, okay, return. This is my favorite topic of this. It's I don't know. It's just the first time you learn it. It's just like what, like the printing and returning and the inputs and all that stuff. So let's just get all those through. So let's make a function. Well, we have that sum function right here. How come when I ran it like this, it didn't print anything? Like I defined the sum and I had it return x plus y, and it didn't print anything. Well, what happened is we returned the value 11, because 5 plus 6 is 11, right? So basically this became 11. So we basically, this file said, okay, Python, I defined this function, and now 11. And now you're done. Like, see, it doesn't ever go there. So if we want to print 11, we would print the 11, right? That's how we print out values. So if we want to print what that function returns, then we would say print what sum returns when I put in 5 and 6. So the way I like to think of it is when you call this, that this like becomes 11, and then you're printing an 11. So yeah. So this gets really confusing really fast too. So then if I just called it like this, let's say I printed x plus y. So that works the same way, right? Sum of 5 and 6. But then, what if I do this? Print sum. So, this says, okay, I want you to print what sum returns. Now, in order to get what sum returns, we have to run the function first, right? So, we're going to have 5 and 6. We're going to print that out. Okay, 11. Now, what is sum going to become? What did it return? Well, it didn't return anything, right? So then what we're going to be printing out is none, right? Because not having a return statement in a function is basically the same thing as saying return none, right? It's like an implicit way of saying none. So when we run this, then this will basically become none, and then we'll get none. Or if we don't have it here, same thing happens. And you can actually do this on an easier thing. What if you say print of 6? Now, this inner print is going to have to run first in order to pass what it returns to this one, right? So it's going to print the 6 to the screen. And what does print return? Well, it doesn't need to return anything, right? Because it just does something. It just sends the value over here. It doesn't send the answer, right? So then this will give us the 6 for when this ran, and then none for when it returned none back to here. So yeah, that's usually when you see none. It's typically when you're printing out a function that doesn't return anything. So yeah, that's that. And let's see. Yeah, I always like to drill that concept a lot. So if you had like 5 squared plus 7, I feel like a lot of students, like, they start out and they just type this and then they're expecting to see something over here. But this expression, say, did return the value. What is it? 25? I don't know. I can't do math. 16, whatever. This just became 16 because it just got returned to the line and didn't go anywhere, right? So in order to print this out, you have to actually print that value, and then return there. And then, so what else can we? How else can we break return? Let's go back to our sum function. So one thing people will try to do sometimes is they'll say return x comma y. They'll try to return 2 things. So if I print the sum of 5 and 6, then, well, I guess not the sum anymore, but you would actually get out this tuple 5, 6. And a tuple is like this list thing that you might not learn at some point. So basically, this sum right here became the tuple 5, 6. And this is sometimes difficult to deal with. So now you can do things with this. If I say let's call this two vowels, x, comma, y. So if I said a comma b equals two vowels of 5 and 6, and then I print a, and then I print, crap. If I print a and I print b, this will be 5 and 6, because this will return a tuple of 5 and 6, and you haven't learned tuples yet, so don't worry about it, but this is like some special Python trick that basically takes the first one and puts it in there, and takes the second one and puts it in there. But what I'm trying to say is that when you return two things, it's typically not doing as you expect. So typically you would want to return some answer or use some global variables or something to do what you want to do. So that's all I can think about with return, just like returning none if there's nothing there. Remember, I guess, yeah, printing is not the same as returning. It looks the same sometimes. If I say some, oh, here we go. Here we can cause some problems. Print x plus y. So this is great, right? You know, I didn't even deal with the return. I can just, okay, I'm just not going to print it, right? I'm not going to get that done. 7 and 8. There we go. So let's say this is great. We printed the 15, but now, what if I want to do something with that 15? The problem is we lost it. If I say x equals this, and then I say, okay, I actually want to say print x plus, let's just print it out. Print it out afterwards. You're actually going to get none, right? Because we didn't return anything from the function, so then x got assigned none. When really this looks like I'm saying, you know, assign x the sum of 7 and 8. So if you want to do this, you would have to return. And then that would work just fine. So remember, printing just shoves it over here and that's it. It's done. But returning will actually replace the call where it got called with that value of 15. So yeah. If you have any other questions about that, if I didn't say that well or whatever, just comments or something. So yeah, let's see. Invocation with name, comma value. So yes, this is important. Let's stick with this. I guess let's make it different. Subtract. Subtract. We're gonna do x minus y. Okay. So I'm gonna make this function, and that's great. So I'm gonna run it, and nothing happens. What? I defined this function. But this is I feel like this is a common thing that you see on these exams. We'll give you this, or let's say, actually, I'm going to do both printing and returning. Now, what will be printed out now? Still nothing, right? And why is it still nothing? Because basically, if you step through this file like you are the Python interpreter, which is how I usually solve those ones, this will first say, okay, I'm defining a function. I might use it sometime. There we go. Oh, I'm done. And then nothing gets printed out, right? So in order to use this, we actually have to turn it on. We have to say subtract 5 and 6. Then this will actually print out that -1, and then we actually returned and printed. So I guess we could also print this and it would give us it twice. But yeah. So remember, you actually have to call the function, which you basically just, a lot of times if you have like a complicated function, like z, all this stuff, you're just like, man, like, that's like a lot of stuff, right? So then typically what people do is they just come up here and copy that. And then, okay, I'm just going to replace these with whatever I want. So, yeah, it's basically called the exact same way you defined it. You just pass in the values as comments. And the first one, the first one will become x, right? And then the second one will become y, etc. So, yeah, that's that. So let's talk about local and global scope over here, and we'll talk about the global keyword. So, first of all, let me take a break. So what is a global variable? Well, I'm going to make one. That's global, right? So what a global is, you can think of global is the same thing as not in a function. So x is global because it's not in a function. So if I define a function, let's say hi, it's not going to take anything in, and I say x equals 2, and then I print x. Now, what will this print out? Now, first of all, you should immediately know that it is not 2 because we never even turned this function on, right? It's just, we just defined it and we never used it. So now if we call hi, now we turned it on. So now this actually got executed, right? X equals 2. But it's still 6, right? Because this is a local x. Because remember, global means not in a function. And is this x in a function? Yes, it is. It was defined in I guess you could say not defined in a function. Or as like a parameter or something. So if we wanted this x to be talking about this one that's just out in the file somewhere, then we'd have to type global x. And this links this one to this one. Right? So it basically says whenever I talk about x in this function, I'm actually talking about this one up here. I don't want you to make your own local x that you're just gonna just throw in the trash. Like I want you to actually like do what I want you, like up here, right? So now if we run this, this will actually reset x equal to 2 because we had x equals 6. Define the function. Oh, we ran the function. Oh, we're talking about this x. We're gonna set it equal to 2. Oh, it's 2. Print x 2. There we go. So yeah, that's what globals. If you have multiple globals, if we have y equals 2, and we want to talk about both of them, you can either say global x comma y. You can also say global y like that. And then, so yeah, that's basically the thing to remember is that if you have a variable that is defined in a function like this, it will basically make its own version of this thing. I'm not sure if you do this. I wonder what this happens. Okay, yeah. So I think actually I was reading about this earlier. You're allowed to like look at the variables sometimes. This is dangerous. I wouldn't do this, but you can like look. You can kind of get away with like printing it and stuff. But if you try to do anything that updates the variable, like if you want like write access per se, then it's going to get mad and say, hey, like when you say this, I'm saying x equals x plus this. And I don't have an x yet, so I don't know what you're talking about. Because this one is not even like remotely related to this one, right? Because that's a global x. This is local x. So, so I see creation and conclusion of local scope. So I guess that was kind of just saying like if I have x equals 3 here, remember this x is not the same as this one. This is local. And it got created inside of hi, and then when hi ends, this variable's gone forever. So let's say I call it z even, just to make it look a little different. So when this function ends, if I want to get that z, like I can't, right? Z is dead. Z is gone. It's gone. You could return it. That would just return the value of z to there, and then you could print hi here like this, but you couldn't access that z because it gets destroyed at the end of the function. Unless you're talking about global variables, if you say global z, and then you're like, oh crap, I have to come up here and make it first, right? Because when you're talking about global, you're talking about here. I think you can actually get away with not having this, and it works fine. But I think you should have it initially, just to make sure it's there. Because we don't want sloppy Python, So. We talked about this, the header. We talked about returning it and how, like, when you, if we returned 6 or 7, wherever you had the function call, it basically, I'm going to put this in a print statement so you can see it better, basically became 7. That's what returning does. And then what else? How we call it? Well, we call it by that. We should talk about parameters a little bit more. So if I take in, let me make a puzzle. All right, here we go. So this is a puzzle for you. I want you to pause the video and I want you to tell me what is going to print out when I turn on this code. So yes, what will this print out when I run it over here? So pause video and give it a shot. So I'm assuming you gave it a shot, so I'm going to run it. And this is the answer. And you might be a little confused here, but let's go through it. So the best way, the master method to attacking these problems is to act like you are the computer and go line by line and figure out what's going on. So First, we have x equals 6. Okay, so we had a global variable x, and we stored 6 in it. Y, we stored a global y, put 2 in it, global z, put 9 in it. Okay, so we have these 3 variables. Now, we're going to define a function. Now, this is just a box of code. It does something when we pass in the x, but we might use it, we might not. So let's just put it aside. That's key to remember. It doesn't actually run when you define it, right? So we just made a function. We might use it. Put it aside. So now we say z equals high, and we're passing in x, which is the 6 up here. So remember, you can think of this as being high of 6. So then, now we go inside of high. Hey, we are talking about this y if we refer to y in this function. So we're going to reassign y to, we passed in, what was it, 6? I'm going to pass in, 6 there. There's the parameter x. So even though it's the same thing as this, it's actually the parameter, which is different from this one, right? But, so we're going to say y, so the 2 equals 6 minus 2. So now y is equal to 4. And you got kind of keep track of them, right? So if I keep track of them down here, this is a good thing to do. So now y, what was it? It was 6 minus 2, so it's going to be 4 now. So then, so we set z equal to what this returns, and what does it return? It returns none, right? Because we didn't return anything. So then this becomes none. And then we ran the function again, and we passed in y to here. And remember, we're allowed to do this. Even though this is called x, we can call this anything we want, and it's just passing in this value of 4, actually, because it's now 4. This is really tricky. Okay, so now we passed 4 in here, so we can think of this as being 4. And we're talking about this y, which is now 4. And then we're going to say y equals 4 minus 2. So that's going to be 2. And this is what we got, right? 6, 2, and none. So we make another one. All right, I have another puzzle for you here. And my tip on this one is to don't overthink it. So I want you to, I'm going to print out each one of these. Actually, I'm going to say print x. I'm typing this, so I guess you could pause it and try it or whatever, but I guess it doesn't really yet. So yeah, I'm going to print out these 3 variables. I want you to tell me what will be printed out. So I'm assuming you've had a chance to try it as I type all this. So what, and yeah, so now don't overthink this one. This is sort of a trick question. So they're all 10. You know why they're 10? So remember when you, I don't think I mentioned this, but when you return something, the function is over. When you see it's return 10, it's like, okay, anything else, like, yeah, screw it. Like, I don't even need to, like, look at this. So, you'll usually see this, like, if you say, like, oh, if x equals 0, I actually just want you to, like, return 0. And then this way that you, like, if x is 0, you end the function return 0, and then it wouldn't even continue with the rest. So then if you have some, like, dividing by 0 thing, like, then you wouldn't have to worry about it, right? So since we have this return 10, I know I put this weird stuff in here just to confuse you, but yeah, so since it just returns 10, then all of these just become, I thought I could do that. There we go. All these become 10. There we go. So 10. Cool. Let's see if I can make another. I'm actually looking at this list. Okay, so we talked about this, and we talked about return. Remember, it ends the function, and then it replaces wherever we called it with that 10, right? And then when we called it, remember, we passed those arguments into the function, and the first one will become this one. And I guess the main thing to remember is, like, these, like, parameters and these globals. And if we didn't have these as parameters, these local variables, say here, these are completely different, right? So, like, or I guess the global scope will not affect this one, and just don't forget that. And one little thing that you can try, little edge case, I guess, is that if you have a x in here, you cannot make it global. If you try to, I'm just going to end the function or whatever. That will say, hey, you can't have it be a parameter and global. That's just something to remember. I don't think there's anything else with those. And then, yeah, we talked about that, how the the variables are created and deleted when function, when the scope is over. Why we like functions? Because they're magic. Remember, the print is easy to just send something right there. And then, okay, so yeah, I guess we can talk about some conditionals, and I might make just like a practice video where we can like do some little practice things. Oh, I see literals right here. These are real simple. These are just like, you know, numbers like see I have a 6. That's a literal. If I have a string, like that is I. It's a literal. It's basically, you think of it as a value. Just like literally, you can think of it as like it's literally 1111. There's literally 11.11. So and there's a few weird things with this. I know, like if you say like 1 times 1.0, then you're gonna get a float out. If anything is a float here. So even if I had like a bunch of integers, just having one float in there is gonna make it the decimal. So try things like that, and then we talked about the true and the false. And oh, here's like the these are fun. Let's talk about different types of quotes. So I'm gonna comment this line out. So we're gonna talk about single and double and triple single, triple double, and escape sequences for internal quotes. Okay. So in Python, you can make strings with single or double quotes. They do exactly the same thing, I'm pretty sure. And then triple is kind of good because then if you have like double quotes in here, you can put double quotes up the wazoo, and you can put single quotes wherever you want to, as long as you don't put a triple, because then when you do a triple C, like it got confused and thought this E was like not part of the string anymore. So typically when you're using triple quotes, a lot of times people will do them for like doc strings or something because they just look nice and big. But it's a lot of times if you having some kind of weird thing where you're saying like don't or something and you want this to not affect these, and you can just put triples. Same thing with doubles. Or you can just escape them every time. And escape is you just put a backslash between them. So if I say like print, if I'm like if I do single quotes, I don't like that or something. But this is going to give you an error, right? Because it's like, hey, like you gave me this string, and then I don't know what this was. Now here's another quote. What happened? So you just escape this and say, hey, Python, I am not ending the string yet. I just want you to literally just put that in there like that, and that will put that little quote in there for you like that. Or you could have just made these double quotes and ignored it, or triple, or triple, double, and all that stuff. So, all right, so that's that, and just play around with those, and then I guess we can talk about. Oh yeah, I guess ifs are pretty simple. So let's go through that. So if we say x equals 6, and I say if x is greater than 10, then print x greater than 10. Then you can do elif x is less than 20. Say, and don't forget your colons, right? Print x is less than 20. So this will actually cover, so if I do else, let's see, greater than 10, less than 20, print impossible, because this will never happen, right? Because if it's, it can't be greater than or less than 20, whatever. So yeah, if we run this, we see x is less than 20. Now what's interesting, yeah, so let's put in this 15. So, whoops. One second. So, screwed up. Yeah, so let's put in 15 like this. And so this is kind of interesting, right? Because 15 is both greater than 10 and less than 20. But we only get the first one out, right? Because it satisfied this if case. And if you have else and elif, it breaks it, like it treats this as a single chunk, and as soon as you have one, it's done with the whole block. So if you had this, then if you change this to an if instead of an elif, then it would be able to do both, right? So if I do this, then now it's allowed to do both of these cases. But if I only want one of these to happen, like if this one is more important than this one, say, then I put that one first, because then that would be the only one that happened. And then, if I change this to like -1,000 and be less than 20. What am I trying to say here? Oh yeah. And then, so what's if I make this less general? If I make this, so if it's greater than 10, I want to say, hey, it's greater than 10. If it's greater than 15, I want to say greater than 15. So then, if I say 10, the first one will run, right? Because because 10 is not greater than 10. So then, yes, this else clause describes everything else. So if I say it's less than something like -1 billion, then this else will catch everything else from this if block. So I guess the main thing to remember is that if you have an elif, that will only even be looked at if this didn't run. So even if you have multiple elifs, then whatever. If you have elifs and else, then as soon as one of these is satisfied, you're done, and you skip all the way over the rest of this stuff. So yeah, and so I think you get that, the if, elif, and else. If not, try it on your own and see the different quirks of it, like changing this to this and this. So, and then putting conditions inside of functions or other conditionals. Well, I mean, you can just put this inside a function if you wanted. It would be part of your function with conditionals. I guess that's the thing. But one interesting thing, if I say if x is greater than 10, and then inside of here I say if x is greater than 20, I print you win. So if I put in 1,000, then this will be we win, right? But we could write this as a different way. So what we can do is say and x is greater than 20. And then so we get rid of this and undent here. And we get, so both of these are satisfied, and then we'd be greater than 20. I guess you could just do this, but I mean, yeah, so basically what I'm saying is you can combine these if statements into like an and or something like that. So yeah. So that's all I have. I think I'm gonna make like a little like practice video or something too. But yeah, if there's anything that you want explained more or want another separate video on or something, just put a link in the comments or put a comment. I'm so tired today. Yeah, just leave a comment or something, or if you see anything I've said wrong too. All right, thank you and good luck.